these are the connecting wires. Okay children, this is highlighted, it is the connecting wire. It is the electric bulb which will glow when the switch is on. Keep watching children. Now the switch will be on, that is the circuit is closed and hence the bulb will start glowing. Okay children. So here we know that current passes from the battery through the wires. Now once again, when the switch is open, when the switch is off, the bulb stopped glowing. Okay children, so this is the basic circuit that you must have seen in your lower classes. So children, we know that current reaches the bulb through the connecting wires from the battery. Okay children, how does the current reach the bulb? When the bulb glows, we can understand that the current is passing through the battery. Okay children, from the battery through the wires, the connecting wires. All these components that we have used here are absolutely solids, isn't it children? The battery and the chemical that we used inside the battery, the connecting wires, the electric bulb, the switch, all of these are made up of solid materials only. Okay children? Now the question arises, can current pass through all the solids? Let us see through a small activity. Children, this is our circuit. Okay, we have a battery here, connecting wires, 2 pins, and LED bulb. Okay children, now we are going to test the electrical conductivity of some simple solids. Children, you have to make a note of what you are observing. Now children, first I am taking an iron nail and placing on the 2 pins here. Children, look at the bulb now. The bulb is glowing, yes. Just look at the pretty colors there. So, which means that iron is a good conductor of electricity. Right children? Next, I am taking an eraser. I am taking an eraser. Okay children? Now, when I am putting, the bulb does not glow. Okay children? When you are putting the eraser here, the bulb does not glow. Right children? Which means eraser is a bad conductor of electricity. Now, let us take a matchstick. A matchstick is made up of wood. Keep it on the 2 pins here children. Is the bulb glowing? No, bulb is not glowing, which means wood is a bad conductor of electricity. Next we will take the safety pin. Keep the safety pin. Observe the bulb children. Yes, the bulb is glowing again. The safety pin is made up of steel, so it conducts electricity. Now we have a piece of paper. Children, are you noting down? Keep the piece of paper children. The bulb is not glowing, which means paper is a bad conductor of electricity. I have a chalk piece. The bulb does not glow, which means chalk piece is a bad conductor of electricity. And then I have a graphite pencil lead. Keep it here children. The bulb is glowing. Yes, the bulb is glowing, which means this is also a good conductor of electricity. Finally, we have a small piece of plastic straw. See children, bulb is not glowing. We know plastic is a bad conductor of electricity. So children, I hope you have made the observations. Now let us see them. So children, you have seen this activity and have understood that not all materials can pass current through them. So children, in the activity we have used a nail which is made up of iron. Did the bulb glow children? Yes, the bulb has glown, which means that iron is a good conductor of electricity. And then we have used an eraser which is made up of rubber. We have seen that bulb does not glow, which means rubber is a bad conductor or a poor conductor of electricity. Similarly, we have taken a pencil lead which is made up of graphite, and yes, the bulb has glown in this case, which means graphite is a good conductor of electricity. Then we took a safety pin made up of steel and the bulb has glown. So steel is a good conductor. And then we have taken a piece of paper and also a plastic piece and seen that bulb did not glow in these cases, which means a piece of paper and plastic are bad conductors of electricity. So children, from this we can easily say that not all solids can conduct electricity. Yes or no, children? It is specifically some type of solids called as the metals only that can conduct electricity, which means which can allow electricity to pass through them. So here children, such type of substances we are calling them as good conductors. Let us define it, children. Materials that allow electric current to pass through them are called good conductors of electricity. Let's read it again. Materials that allow electric current to pass through them are called good conductors of electricity. All metals are good conductors of electricity. Okay, children? Now, what are bad conductors? So, let us define what are bad conductors. The materials that do not allow current to pass through them are called bad or poor conductors of electricity. So, children, materials like plastic, rubber, wood, paper, they cannot allow current to pass through them. So, they are called as bad conductors of electricity. Paper, plastic, wood, chalk, rubber, etc. are some of the poor conductors of electricity. Right, children? I hope you understood the difference between good conductors and bad conductors. So, why do some material allow electricity to pass through them and some material don't? This is the question, children. We have seen now that there are good conductors of electricity and bad conductors of electricity, right? There are some materials which immediately allow current to pass through them and some materials that are not at all allowing current to pass through them. So, what is the reason? What is the difference between these substances? The difference is a property called as the electrical conductivity. Yes, children? Every substance has a property called as electrical conductivity. It is a property of any given material, not just for good conductors, children. Electrical conductivity is a property which can be ascribed to non-conductors also. If a material has good electrical conductivity, then it allows electric current to pass through it easily. So children, good conductors of electricity, they have high values of electrical conductivity. So metals like iron, silver, copper, nickel, all of these, children, they have very high values of electrical conductivity. So they allow current to pass through them easily. Whereas bad conductors of electricity do not have high values. They have very, very low values of electrical conductivity, children, because of which they cannot pass current through them. Look at some more questions. I want you to think about the situations here. Elders at home warn you against touching the electric switches with wet hands. Yes or no, children? Our parents at home, elders at home, when by accidentally or by mistake, if you are trying to touch the electrical switch with wet hands, they warn you against it, children. Yes, you must not put your hand to check the heat of water while the water heater is connected to the power supply. So this is a common thing, children. The water heater, the electric water heater, we usually immerse it in a bucket of water. The power supply is given and by mistake we may try to check the heat of water by putting our hand directly without putting off the power supply. So even this is dangerous. Our parents also keep warning us against this. You must not stand near electric poles when there is a heavy rain. Yes, children? This is also one of the common things that we are warned against. When it is raining heavily, we are not supposed to stand near the electric poles. We have heard about farmers dying due to electric shock when they touch the switch of the motor pump. What is common in all these situations? Yes, water. In all these situations, we can commonly see is water. Isn't it, children? Wet hands means we have water on our hands. And checking the heat of water, the electric heater is immersed in water. Yes. When it is raining, standing near the electric poles, of course, rainwater. And then the electric pump. When the farmer tries to switch on the motor pump, sometimes he is electrocuted and he may die instantaneously. The most common thing in all these situations is nothing but water, children. What do we understand from this? Yes, of course, water can conduct electricity. Yes, this is what we understand from this. Water can pass electricity through it. That is the reason we are supposed to stay away from the electric poles when it is raining and not to touch the switches with our wet hands. Water is a good conductor of electricity. That is, we have understood now. It is dangerous to touch electrical appliances with wet hands. Very, very dangerous, children. Then, like water is a liquid, what about other liquids? Do other liquids also allow electricity to pass through them? So, let us try to see this with another activity. So, children, observe the activity carefully and you keep noting down whatever you are observing. Now, children, let us look at the electrical conductivity of some of the liquids. Here also we have a battery, a LED bulb, connecting wires, and this is a homemade tester, okay, which you can also make. We have made use of 2 nails for electrodes, right, children? We are going to begin with distilled water, children. Now I am going to put this tester in the distilled water and check if the bulb is glowing or not. So, children, this is a very feeble glow. Children, remember to wipe the electrodes every time with a tissue paper. Next, children, we will take the drinking water. Look at the bulb, children, now. Is it glowing? Yes. We can see that the bulb is glowing. Next, children, we have the lemon juice. Keep observing the bulb, children. Look how nicely the bulb is glowing, which means lemon juice is a good conductor of electricity. How is the glow of the bulb compared to the metals, children? Not as good, isn't it? Now, I have sugar solution here. Almost a no, children. The glow is not very good. The next one I have is salt solution. Yes, a very bright glow, children, you can see for salt solution. Children, the next thing I have is vinegar. Look at the bulb, children. Once again it is glowing very brightly, which means vinegar also conducts electricity. Finally, we have taken the vegetable oil. Okay, children, this is the vegetable oil. There is no current passing through vegetable oil, children, which means vegetable oil is a bad conductor of electricity. Right, children? I hope you have noted down the conductivity of all these 7 liquids that we have used. Let us look at the tabular column, children. So, children, we have seen this activity and we have seen in some situations the bulb has glown and in some situations the bulb has not glown. So, let us look at all the results in one place. Right. The first thing we used was the distilled water. Distilled water is pure water, children. All the minerals are removed from this. Okay. So, we have seen that bulb does not glow when distilled water is used, which means distilled water is a bad conductor of electricity. Then we have taken drinking water. Yes, bulb has glown here, which means it is a good conductor of electricity, or we can always use the tap water also. So, children, we can always see here distilled water and drinking water are different. Distilled water is pure. Lemon juice, yes, it is a good conductor of electricity. Vegetable oil, no, it is a bad conductor. Vinegar, yes, it's a good conductor. Salt solution is a good conductor of electricity, and sugar solution we have seen the bulb has not glown, it is a bad conductor of electricity. So, children, in this we have seen that all the liquids cannot conduct electricity. All the liquids cannot pass current through them. Right, children? What do we conclude from this activity? Drinking water, lemon juice, vinegar and salt solution are good conductors of electricity, whereas distilled water, vegetable oil and sugar solution are bad or poor conductors of electricity. We have also observed that the intensity of the light was not as good as in metals. So children, while performing the activity, we have noticed that the glow in the bulb was a little bit lesser compared to the use of the metals. Yes children? Also, in some liquids, the bulb had glowed very brightly and in some it was less bright. It was a little bit dull. It is because the intensity of the glow of the light, the LED, depends upon the flow of electric current through the circuit. Okay children? So the intensity depends upon how much current is flowing in the circuit, which means that although some liquids are good conductors of electricity, they may not allow current to pass through them easily, which causes a weak current in them. So children, it is simple to understand. Metals are very good conductors of electricity, whereas liquids, though they may be good conductors of electricity, but current may not easily pass through them. Okay children, not as good as in metals. So we have to understand here one question children. When do these liquids conduct electricity? Why is it that some liquids are able to conduct electricity and some liquids are not able to conduct electricity? Why is distilled water a poor conductor while drinking water is a good conductor of electricity? See children, difference here. Distilled water, drinking water, both are water. Both of these chemical composition is the same, right? H2O and H2O. But we are saying distilled water cannot conduct electricity, whereas drinking water can conduct electricity. Right children? We will see the reasons. The electrical conductivity of an electrolyte. So children, again we are going to see a demonstration. Here we are going to check the electrical conductivity of distilled water when dissolved with different substances. So here children, electrolyte is an aqueous solution of water with some other substance like salts. Okay children? So to check the electrical conductivity of distilled water when dissolved with different substances, we use for this activity distilled water, salt, copper sulfate, lemon juice, some containers and a tester. Tester is to check the passing of electricity. It is nothing but we have taken a small bulb and we'll check if the bulb glows or not. So let us see the activity children. Once again, you have to note down whatever you are observing. So first we are taking pure water or distilled water children and check the conductivity. Make sure that you wipe the electrodes properly so that other liquids are not left on the electrodes. Pure water is not a very good conductor children. The bulb is glowing very feeble, so it is almost a no. Next children, we are taking a solution of copper sulfate. Children, can you see the blue color children? Yes, it is copper sulfate solution. When you keep the tester inside, yes, the bulb is glowing very brightly. Yes or no children? That means copper sulfate solution can also conduct electricity. Next we are going to take salt solution in distilled water. Salt in distilled water. Yes, when we mix salt with distilled water, it becomes a good conductor of electricity. Finally, we are going to take lemon juice in distilled water. Lemon juice in distilled water. Yes, again the bulb is glowing, which means distilled water singly is a bad conductor, but when it is mixed with acids, bases and salts, it is becoming a good conductor. We have observed that pure distilled water does not conduct electricity, whereas when you have mixed these substances, salt, lemon juice or copper sulfate in it, it started to conduct electricity. I hope you understand this children. So here we saw distilled water did not conduct electricity, so it is a bad conductor. Whereas when we mixed salt with distilled water, the bulb started glowing, which means this solution of distilled water with salt is a good conductor of electricity. And then distilled water and copper sulfate. Yes, it has also become a good conductor of electricity. And then the solution of distilled water and lemon juice also conducted electricity. So the combination of distilled water with lemon juice is also a good conductor of electricity. Now let us write the conclusions and observations what we have seen in this activity, children. Water in its pure form is called distilled water. This is a poor conductor of electricity or a bad conductor of electricity. Water turns into a good conductor of electricity when mixed with salts, acids or bases. Water that we use in our daily life for different purposes contains salts and other minerals. Hence, it is not in its pure form. Okay, children? So, water that we are using in our daily life contains some minerals in it. Okay, some type of salts in it. Therefore, it is not said to be in the pure form. Okay, children? Some of these minerals are essential for our health. Yes, these minerals should be there in water so that when we are drinking it, our body receives them. Okay, children? We cannot consume distilled water. It does not contain any type of minerals. In the activity that we saw, distilled water when dissolved with salt, copper sulfate and lemon juice became a good conductor of electricity. Now children, I hope you understand now why we are not supposed to touch electrical appliances with wet hands, because the water, the rain water or the regular water, the ground water, the tap water, all these water have some salts and minerals present in them which cause the water to be a very good conductor of electricity. So, if we are touching these appliances with wet hands, there is a chance that our body will receive the current passing through the appliance and it may be very dangerous for us. Water with salts is a very good conductor of electricity. Okay, children? The current flowing through household appliances is very high. Okay, children? The value of current, the amount of current flowing in our household appliances is very high. Therefore, we should never touch the electrical appliances with wet hands. Remember, children, if you have to work with electrical appliances, always wear rubber gloves or wear rubber slippers. Okay, it is better to wear rubber gloves and work on a plastic or wooden chair. Most liquids that conduct electricity are solutions of acids, bases or salts. Okay, children? So, in this activity, you might have understood that whatever liquids that have shown electricity are solutions of acids, bases or salts. So, children, we have come to the end of this session. Now, let us see what we have learned in today's session. Materials that allow electricity to pass through them are called good conductors of electricity. Materials that do not allow electricity to pass through them are called bad conductors of electricity. Learn these definitions, children. If the material has high electrical conductivity, then it becomes a good conductor of electricity. Some liquids are good conductors of electricity. Water in its pure form, that is distilled water, is a bad conductor. When pure water is dissolved with salts, acids or bases, it becomes a good conductor of electricity. So, this is what we have learned today. Most liquids that are good conductors of electricity are solutions of acids, bases or salts. Now, let us see some questions. You have to think and answer, children. Guess the consequences if all the solids were good conductors of electricity. We have seen that some of the solids cannot pass current through them. I want you to think about it. What will happen if all the solids can conduct electricity? Okay, like wood, plastic, paper. All of these also start conducting electricity. What would have happened? What are the applications of electrical conductivity in liquids? Where are we using them? Why are we advised not to touch electrical appliances with wet hands? And mention few precautions to be followed while working with electricity. I hope you all have understood today's session and also followed the demonstrations clearly. Children, try to answer the questions given at the end and also try to answer the worksheets provided by SCRT. Thank you, children. Have a nice day.
పిల్లలు